All right, so here we are in section 2, which is all about factoring. So this is definitely a skill that we need to know and master, especially working with second degree polynomials, like quadratics and things like that. As far as like our perfect cubes, things like that, that'll come with some time, but I still want you to have this in your notes so you can reference it at some point. Now, one thing that you want to keep in mind when you are factoring polynomials is you always want to make sure that you're taking a look at looking out for having greatest common factor, so that GCF, because that a lot of times can make things simpler for us. So as I look at what I've got here, I got 24y to the fourth minus 54y to the third. So when I see this, number one, I see that I've got y's in both of the terms here. And then when I look at the 24 and the 54, I know both of those are divisible by 6. So if I take out a 6, and I'm also going to take out 3 y's, so y to the third, that's going to leave us behind with 4y minus 9, and that's factoring out the GCF. Now, the 4y minus 9, I can't do anything else with it. I'm going to leave it like that. Looking at number 2 right here, if I take a look at the 51 and the 17, I can actually divide both of those by 17. So I'm going to take out a 17. When I look at the a's, I've got a to the 8th and a to the 3rd. So that means I could take out 3 of the a's. So I'm going to take out a to the 3rd here. And then b to the 4th and b to the 5th, I can take out 4 b's. Now, 51 divided by 17 is going to give me 3. And if I have a to the 8th and I took out 3 of them, that leaves us with 5 left over. B to the 4th, I took out all of those, so I won't have any b's left. Now, don't forget that you got to leave a value here. 17 divided by 17 is 1. I don't need to put that there. I took out all 3 of the A's, and then of the 5 B's that I have, I'm going to have 1 left over. So 17, A to the 3rd, B to the 4th is going to be our GCF. All right, so now the next one's here. Taking a look at the difference of perfect squares. This is one that you want to be able to, again, recognize. When we're talking about difference, that doesn't mean that we're talking about subtraction. We are talking about something like x squared minus y squared when you're subtracting two perfect squares. Now, to make this helpful for you, you should know your perfect squares. So 1 squared is 1, 2 squared is 4, 3 squared is 9, and if I keep listing them out, these are our perfect squares. Now, when I look at these numbers here, and this is just going up to 10 squared, obviously it continues on, these also come in different forms as well. Sometimes we see them in fractions, like when you look at number 4 right here, we see it 1 over 144. That actually is a perfect square. And when you factor perfect squares, because there's the difference between them, what happens here is when you factor and then you FOIL it out, those middle terms are going away. And so we get factors of x plus y and x minus y. That right there is really important for us to grasp at this point. So that's the identical factors, but one is adding and one subtracting. And when you FOIL, the O and the I of the FOIL cancel out, and that's why we're just left with the perfect squares at the end. So 36w squared minus 25. 36 is a perfect squared. That's 6 and 6. 25, that's 5 and 5. So really what I'm looking at here is this 36w squared. We could rewrite that as 6w squared. And then minus 25, well, that's the same thing as 5 squared. So now this 6w right here, this is my x, and that 5 is my y. So as I go to factor, I am going to get here 6w plus 5 and 6w minus 5. 6w times 6w gives us 36w squared. 6w times negative 5 is negative 30w. And then the 5 times 6w is a positive. And what's 30w? And so that's going to cancel out. And then 5 times -5 gives us the -25. Okay, take a look at number 4 here. 1 over 144. So if I were to continue with my perfect squares here, so I'm trying to think here. So if I go 11 squared, so 11 squared is 121. 12 squared is going to give us 144. If I rewrite this, I can think of this here as 1/12 squared. I square the top and the bottom number there, minus, and then here I have to be careful. So r to the 6th and s to the 4th. So if I'm squaring these, remember when we take powers, we multiply them. So this would be the same thing as r to the 3rd s squared, all being squared. All right, so that's the exact same thing. Notice right here that the 1/12, well, that's my x, and this r cubed s squared, well, that's going to be my y. So I'm going to factor this out. I've got 1/12 plus r cubed s squared, and then I'm going to have 1/12 minus r cubed s squared. Look at number 5. So you substitute in here saying, all right, well, the 16x to the 4th, we could go ahead and think of that as 4x squared. And then I've got the 1, and well, 1 squared is 1. The only problem is notice there is a plus, and we are talking about the difference. This right here cannot be factored. It is a prime polynomial. You cannot factor that. It's impossible to do that. Now, if it would have been 16x to the 4th minus 1, we would have been okay. Let's take a look at number 6 here. The 9 is a perfect square. 100 is a perfect squared. When I see my powers here, they're all even numbers, so that's good news for us. I can rewrite this as 3a squared b squared minus 10c squared, and that will give me what I need. So my factors here is going to be 3a squared b. Oops, I don't want that parenthesis quite there yet. And I'm going to go plus 10c, and then 3a squared b minus 10c. And that right there is the difference of squares. Well, there also is working with the sum and difference of cubes. And this is one that you probably will not have memorized, but it's something to definitely have in your notes to look back to. It'll pop up a little bit later on. First of all, cubed numbers, we're talking about 1 cubed, 2 cubed, 3 cubed, all that good stuff. So we start out with 1 cubed, well, that's 1. 2 cubed is going to get 8, so it's 2 times 2 times 2. 3 cubed is 27. 4 cubed is 64. And if I keep doing this, I'm just going to list out the first couple cubes here. This is just a couple of the perfect cubes that are out there. Now, notice that there is a formula for the sum of cubes, and there's one for the difference of cubes. When it comes to our rule for factoring here, if it is x cubed, and we're doing the sum here, so plus y cubed, what happens here is we are going to take that value of x plus y, and then we're going to multiply it by x squared minus xy and plus y squared. And that's as far as it can be factored. So when I see h cubed plus 125 right here, I'm going to think of this as, okay, I've got h cubed plus 125. Well, that is 5 cubed. So now, like we did up above, here this h, that's my x, and the 5 right there, that is going to be my y. So when I plug it in here, I have x plus y, so h plus 5. That's my first step. And I've got x squared. Well, x squared is h, so h squared minus xy. Well, x and y is 5 and h. So I'm going to go 5h plus y squared, so 5 squared gives us 25. Okay, let's take a look at 8f to the third plus 27. I can think about this right here as 2f to the third plus 3. Yes, 3 to the third right there. And so here my 2f, that is going to be x, and my y is going to be 3. So what I'm doing right here is I'm just plugging these values right up into this equation right here. So when I see that x is equal to 2f, where I see an x, I'm plugging in 2f. And then where I see a 3, I'm going to be, or y, I'm going to be plugging it in for 3. So I've got x plus y, so 2f plus 3. And the second set here is going to be x squared. Now be careful here, it's 2f squared. So that's going to actually give me 4f squared minus xy, 2f times 3, so that would be 6f plus y squared, so that would be 3 squared, which is going to give us 9. All right, let's take a look at number 9. And if you've got this, you probably will be able to maybe start fast forwarding through this a little bit. 27a to the third. So 27 we are referring to as 3. So 3a cubed plus 512. So that's 8 to the third right here. So I've got 3a will be my x, and then my 8 is going to be my y. So I'm going to do, oops, it's a thick marker. All right, so we're going to do x, which is 3a plus 8. And then we have to take x and square it. So 3a squared is 9a squared minus x times y. So 3 times, what am I doing here? So I'm doing 3 times 8. Yes, so it's going to give us 24a plus an 8 squared, which is going to give us 64. All right, so I'm going to move on to the difference of cubes. And the thing that's different about this is we are going to now take, we're going to be doing a cubed minus, oh, I wanted to keep it the same, we'll do x and y, sorry. So x cubed minus y cubed. We're just going to start out with x minus y this time, and then it's going to be x squared plus xy plus y squared. So I look at 11 cubed minus 343. So that right there is the same thing as x being cubed minus, and let's see, 343, that's the same thing as 7 cubed. So here my x is going to be x, and my y is going to be the 7. So I've got x minus 7. I've got x squared plus 7x plus 49. Okay, 125 minus 8v to the third. So I could think of this as 5 to the third minus, and then I'm going to rewrite this as 2v to the third. So my x is the 5, my 2v, that is my y value. So I got x minus y, so 5 minus 2v. X squared, so 5 squared, that's 25. I need to put a plus here. X times y, so that's going to be 10v. And then lastly, plus y squared, so that's 4v squared that we will be looking at. All right, so I think you guys have gotten a clue on that part. So let's jump up here. So what I'm just going to do real quick, and maybe you want to try and do 13 and 14 on your own, and even number 10. So what I'm going to do right now is I'm going to pause my video, try and see if you can do 10, 13, and 14 on your own, and then restart it and see if you get the right answers. All right, there we are for 10, 13, and 14. All right, the next thing is going to be getting into the factoring of trinomials, which hopefully you are pretty comfortable doing. I also want to talk about how do you factor a four-term polynomial doing the grouping method, because sometimes that's helpful for us. And lastly, just talking about making sure that we always factor completely. So with trinomials, I guess if you remember back in geometry, we spent some time doing this, and I work with you guys, and we kind of like set up the box and do it that way. Here, I want you to, starting to develop it in your head. When you are factoring, you're trying to undo that FOIL process. So as far as the m squared goes, m times m is going to give us that. And then looking at this last part here, which is the negative 30, I need to have two numbers that are going to multiply together to be negative 30. But remember that when you FOIL this out, you need the O and the I to add up to be the negative 13. So typically, two numbers that multiply together to give us negative 30, but add together to give us negative 13. And what will work for that is negative 15 and positive 2. So now m times m is m squared. M times 2 is 2m. Negative 15 times m is negative 15m, plus the 2m gives us the negative 13m. And negative 15 times 2 gives us the negative 30. So there's our factors. Taking a look at the next one here, a squared plus 11a minus 80. So when I look at factoring here, I've got a times a. And now two numbers are going to multiply together to be negative 80 and add together to be 11. So that's going to be plus 16 and negative 5. So notice that 16 plus a negative 5 gives me 11. That's going to be that O and that I of the FOIL. Now, what about the x to the fourth right here? Well, what's going to give me x to the fourth? Here, I can just do an x squared and x squared. The reason I want to do x squared and x squared is I want that middle term to be a negative 1x squared. So this would allow me to have those like terms. Now, two numbers are going to multiply together to give me negative 20, but add together to give me negative 1. That's going to give us a negative 5 and a positive 4 in that place. Now in 18, 19, and 20, you've got to be careful because the same rule that I did for the first three, I can't really apply to here because, well, it's got a 2d squared, a 10g squared, and a 16w to the fourth. So you have to realize that there are no two numbers that are going to multiply to be negative 7 and add to be negative 13. It's just not possible. And that's just because you have some other terms that are going to be affecting our FOIL process in this. Now, there are different ways to do problems like this, and if you're really struggling, you can look up different options that are out there. You can also contact me if you're having problems with this, and I can show you some different options for you to at least try. But I'm just going to go ahead and start here. So 2d squared, pretty much since 2 is a prime number, we've got our options are 2d and 1d. That's the only thing that's going to work for us. And negative 7 is also a prime number, so I only have options of 7 and 1. Now I do have a negative that's there. I have to now somehow get negative 13. If I go ahead and put a negative 7 here and a positive 1 here, as I FOIL this out, 2d times d gives me 2d squared. 2d times negative 7 is negative 14d. The inside terms plus 1d, and 1 times negative 7 is negative 7. Notice right here, the negative 14d plus 1d, well, that gives us the negative 13d. And so our factors are going to be 2d plus 1 and d minus 7. Notice that that 2d times that negative 7, that's what's giving us that negative 13 and helping us get to there. Looking at number 19 here, now I've got a couple more choices because I'm not working with prime numbers anymore. So 10g squared, we could do 10 and 1, we could do 5 and 2. You have some more options. Personally, I always like to try with a 5 and a 2. So let's go 5g and a 2g. Then I've got a positive 9 that's here. So I've got really 3 times 3 or 9 times 1. Now notice that it's a positive 9. Notice that the middle term is negative. That means that I'm going to have to do a negative times a negative. And I'm going to go ahead and do negative 3 and negative 3. So now as I FOIL out, 5g times 2g is a 10g squared. 5g times negative 3 is negative 15g. Negative 3 times 2g is a negative 6g. Now notice right there, that's good news for us because that's giving us the negative 21g. Negative 3 and negative 3 gives us positive 9. So right there, here, we're getting that negative 21g. So here are our factors. All right, number 20, take a look at this one real quick. I've got 16w to the fourth, so we got 1 and 16. You got 2 and 8. You got 4 and 4. Again, I typically like to try out like a 4 and a 4. I try and go with like the middle of the road. Usually, unless I see like a really large number in the center here, which 40 is pretty big, but let's see what a 4w squared times a 4w squared will do for us. I've got a plus 25, and I do know that 4 times 5 is going to give me 20. So let's put a plus 5 and a plus 5 here. Notice that when I FOIL, I get a 16w to the fourth plus 20w squared plus another 20w squared. Oh, there we go. Perfect. There's my 40w squared plus 25. So we are golden here. We have 2 factors. All right, so that's factoring trinomials. What do you do if you have 4 terms? And if you like this method, let's say you're struggling with 15 through 20 right there, take a look at what I'm doing right here for 21 through 24, because you can actually use this process right here to help you do problems like 15 through 20. You can look it up, or you can ask me and I can help you out. What we do in this 4 terms situation here is we use a method called grouping. Some textbooks call it chunking. I prefer to use the word grouping. And what we're going to do is we're going to use a little bit of our GCF method, and we're going to group together. So take the first 2 terms and the last 2 terms. Take out the GCF. And so in that first group here, I'm going to take out h squared, and I'll be left with a 2h minus 3. Over here, I've got a 6h minus 9, so we could take out a 3. And we're left with a 2h minus 3. Now, what's unique about this right here is you'll notice that once you take out that GCF, you're left with the exact same thing inside these parentheses here. And the GCF that's taken out in front, that's actually going to be one of our factors, and our common one is going to be the other factor. So what the GCFs here, the h squared plus 3, that's going to be one factor, and 2h minus 3 is the other. The reason why we're getting 4 terms up above is because you're using FOIL, and you're just not having the O and the I terms, those middle terms, combining it to being like terms. And that's what's taking place. So h squared times 2h is 2h to the third. H squared and negative 3, that's the negative 3h squared. You are just undoing the FOIL process. That's the grouping method. All right, take a look at these 2 groups right here. Z to the third plus 7z squared. I'm going to take out a z squared and be left with a z plus 7. Over on the other side here, I am going to take out a negative 5 and be left with a z plus 7. I want the leftovers here to be the exact same thing. And then, then I can take my GCFs that I got out of there. So z squared minus 5 is one factor, and z plus 7 is the other. All right, so number 23, here I could take out a 3r squared and be left with 2r minus 3. On the other side here, I'm going to take out, let's see, I can take out a 5 and be left with 2r minus 3. Again, notice that we have both of them, the 2r minus 3. So take the GCFs, 3r squared plus 5 and 2r minus 3. All right, try and see if you can do number 24. All right, so you should get for number 24, 4c squared plus 9 and c plus 5. Don't mind, I don't know if you can hear my dog panting in the background right now, but it's a little warm. All right, last thing that I want to leave you with, and actually I'm going to have you guys probably try some of these on your own, is just being able to try and see if you can factor a polynomial completely. This will come into play, especially when we start working with our polynomial unit, trying to find all of our zeros. If you can do this on your own, then you don't have to do the long division, the synthetic division type of stuff, and that'll get you your solutions. Otherwise, there's another way around it. But when you are working with factoring a polynomial, you always want to make sure that you're checking to see if you can take out a GCF, because that will always make things a little bit easier. So here I've got a 5n to the fifth minus 180n. So I know right away I can divide both of those by 5, so I can take out a 5 and I can take out an n. This is going to leave us behind with n to the fourth minus 36. And that n to the fourth minus 36, well, that's the difference of two perfect squares. And so this is going to give us n squared plus 6 and n squared minus 6. So using these factoring techniques that we talked about. If I take a look at number 26 right here, now I could go ahead and factor it as is, but if I make it a little bit easier on myself now, even what I always suggest here is factoring out even the fact that your leading term here is a -6. I can divide -6, -14, and -4 all by -2, and that will give us a positive 3k squared. That's going to give us a positive 7k, and that's going to give us a positive 2. These are much easier ones to work with, and especially that now I'm going to try and factor this out. I'm working with factors of 3, which 3 is a prime number, so really my only option is 3k and 1k. Also factors of 2, which is 1 and 2. So I don't have as many options. But as I look here, that's going to give me my factors. So what I would suggest that you do here is try and see if you can do 27 through 32, factoring them out completely. And pause it and then start it back up and I'll show you the answers. All right, so here are the last 6 to take a look at. And there we finished section 2, which is factoring.